Hello, my name is Farooq Enayati Ahangar. I want to tell you about an optimization model we use to reduce spoilage of pasteurized milk, and with that, optimize the length of milk shelf life. First, let me tell you what optimization models are. Optimization models use mathematics to find the best solution to a problem. They have many applications in our daily lives. For example, we all try to minimize the time needed to prepare for work each morning. By doing that, we solve an optimization problem. Just to name a few optimization applications. In communications, we have ad scheduling problems. In the distribution sector, we have inventory optimization problems. In finance, we have portfolio optimization problems. In industry, we have space or layout optimization problems. And we have medical staff scheduling problems for the public sector. To solve an optimization problem, first, we need to describe the problem. That means specifying what we need to maximize or minimize, what the constraints and limitations of the problem are, and what simplifying assumptions we need to make to be able to model the problem. Next, we translate the description of the problem into a mathematical model. During this process, we use input data collected from resources such as surveys, online resources, literature, lab results, or expert opinions. Then we solve the problem, typically using a specialized software program such as Python or C++ that uses optimization libraries such as Groovy. Finally, we will have our optimal solution. Let me now describe our study in which we used an optimization model to solve the problem of premature spoilage of pasteurized milk. First, let me explain the supply chain for pasteurized milk. The supply chain starts with farmers, aka producers. They milk their cows every day. The raw milk will then be picked up by tanker trucks and it will be sent to the processing facility and stored in silos for processing. After the processing is completed, which includes pasteurization, the pasteurized milk will be packaged and sent to retail so it can be available for consumers to purchase and later consumed. Unfortunately, sometimes milk gets spoiled prematurely. This shortens the shelf life of milk, and because milk has to be thrown away before it is consumed, spoilage contributes to food waste. But what causes milk to spoil prematurely? One cause of early milk spoilage is spore-forming bacteria. They can enter the raw milk at the farm, survive commonly used pasteurization methods, and grow in milk packages even at refrigeration temperatures until their numbers are so high that the milk looks and tastes bad. So to increase milk's shelf life, these spore-forming bacteria must be controlled. The question is, where should dairy processor invest to extend milk shelf life to keep the consumers happy and reduce food waste? There are three main actions that they can take to reduce spore-forming bacteria levels in pasteurized milk. The first one happens at the farm level. The processors can create a premium system that penalizes and or incentivizes farmers based on the level of spore-forming bacteria in their raw milk. They can also use spore reduction technologies to reduce the bacteria already in raw milk. These processes are called microfiltration and bactification. Both of them require very expensive equipment but can reduce bacteria levels dramatically. The question now becomes how the processors should invest in these interventions based on their limited budget so that they can increase milk's shelf life and eventually their profit. Now that we define the problem, the next step is to describe the model mathematically using input parameters and data and also decision variables. This is what our model looks like. We've developed our mathematical model using parameters such as the number of days in the planning horizon, total daily budget, and costs of purchasing microfiltration or bactification units. For some of these parameters, we had to develop a Monte Carlo model to simulate thousands of milk packages with different levels of bacteria contamination to predict the average shelf life of all the milk packages. And variables, such as the one that shows whether or not we should have a premium payment system or microfiltration, or the decision variable representing the average shelf life, which is what we want to eventually maximize. In our integer programming model, the objective function is to maximize the average shelf life of pasteurized fluid milk. The rest of the model are relationships between the variables and the parameters, and also constraints that represent the limitations we have for the problem. For example, we cannot spend more than the daily budget that we have each day. Once the model was constructed, we solved it to get the optimal solution under different scenarios. Different software programs can be used for model solving. For this project, we use Python as our programming language and Groovy as its optimization library. After running the model under different production and processing scenarios, we concluded that this is not a one prescription for all kind of a problem. We found that the optimal solution is highly dependent on a number of factors. For example, how big is the milk processor? What is the volume of milk it processes? If it's not large enough, then purchasing a piece of expensive equipment to reduce bacteria level is not justifiable, unless they can allocate enough budget for this. This means that the processor's daily budget can play an essential role in the optimal solution. The results also suggested that the quality of raw milk supplied by farmers is essential. If the raw milk is too contaminated to get the optimal shelf life, the processors can be forced to apply larger penalties or purchase microfiltration or bacterification units. To wrap up this video, I can say that optimization models generally help us investigate thousands or millions of possible solutions, and they find the best one according to a specific goal. Our optimization model for pasteurized fluid milk shelf life does the same thing. It is capable of finding optimal solutions for different milk processors with different milk volumes and budgets, just so they can reach the maximum shelf life and eventually profit while making consumers happy. For those of you who would like to know more about this optimization study, it is available in the Journal of Frontiers in Sustainable Food Systems. Thanks to my co-authors in the study, Sarah Murphy, Nicole Martin, Martin Widman, and Renata Ivanek. And also thanks to the Foundation of Food and Agriculture Research for funding this study. And finally, thank you for watching, and feel free to contact me if you have any questions about this study.